Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis from Autodesk, and on the keyboards today I have my friend Angelo. So as we're going through, if you have any questions, please feel free to post them out into the chat, and if they're important, he'll send them to me. And today we're going to be working on this guy. So this is part of the pencil sharpener assembly. So we're going to create this plastic base, and then we're going to work on some of these gears that you see. So let's dive right in. Okay, in the YouTube video I have included the outline that I created. I've also included the drawing set, which you see here. So there's multiple sheets, so I'm going to be using the dimensions you see on this drawing set. So we're going to create a couple of these gear shafts, and then I also included the information on creating these two different kinds of gears that we'll be using. Okay, so this is going to be our final design for today, mainly working on the top of this plastic part for today. Okay, so what I'm going to do is, again, we're going to use existing geometry to help me out. So I'm going to isolate this gear housing, and I'm going to create a new component. So we're going to be using information from this, but I want to create a new component. And one of the easy ways to do this is to right mouse click in your browser and say new component. And you're going to see me do this a lot today. And the reason I like this method is because you can tell it where you want that component to go. If I came up here, I could say new component, but I'd have to tell it, you know, what's its parent and all this kind of stuff. And that can get a little bit confusing. So I'm going to just right mouse click here, say new component, and I'm just going to call this motor gear base. Motor gear base. I've also, in the description of the video, I also included an export of this whole assembly for those of you that haven't had the time to create the whole thing. I put it out there, that way you can load it, scroll through the timeline. If you want to continue on from a certain step that I've done, maybe episode 7 or something like that, you don't have to start from the very beginning. So if you need to download it, it's also in the description. Okay, so I now have this component called motor gear base. You can see that it's active, which is great. And then I'm going to create a sketch. So I'm going to, basically this part kind of butts up against this other gear housing right here. So I'm going to put my sketch right on that face, and I'm going to project. So I'm going to hit P for project. And I like to rotate so I can see which edge. So you'll notice like there's an edge here and there's an edge here. Does it really matter? Not really. But like if I'm looking at it straight on, I have kind of a harder time seeing which edge I'm actually selecting. So I like to rotate slightly, and we're going to project that edge right there. Just a little tip that I do. Okay. Don't need the gear housing in the way anymore. And I now have the edge projected from that gear housing. We're going to give it a little bit of clearance, so I'm going to do this offset command, or you can see the shortcut key is O for offset. I'll click on that edge, and I like to start to drag, and I want it to go in, and you'll notice when it's going in, it's a negative number. And that's why I like to drag, first of all, is to see, oh, I need to make sure I put a negative 0.01, so 0.01. And if we zoom up, you'll see there's the projected edge, and there's our new offset edge. Okay, so let's do a circle on this new edge. Now you'll notice it's going to try and snap to that edge, so I'm going to get close to that. I want it to be right here, but you'll notice it's not like snapping horizontal, so I like to over-exaggerate just a little bit, so I'm going to come up a little bit. And this is going to be a 0.5 diameter circle. Okay, and we can see it's still blue, which means it's not totally constrained. But if I come in here and do a horizontal vertical, I'm going to say I want that point to be horizontal with that point. We can now physically see that it moved into place, it's perfectly horizontal, and it's fully constrained. Okay. So now I'm going to, you'll notice it's projected, both the outside and the inside edge. So I'm going to make sure I grab both of these profiles. I don't want to grab this little sliver right here because that's what we offset. And now I can say extrude. So right mouse click, extrude. Again, I like to start to drag to kind of see what direction, what the number is. In this case, it's a positive number. So 0.175. And we've kind of started with the basic shape. So again, looking at the drawing, we kind of just drew, actually let me go to the next sheet. We basically drew just this flat disc right here. Okay. Okay. It's shelled out, so looking kind of from the bottom of the part, and you can kind of see, I can use my cube to help me out here. I'm looking kind of up at the bottom of the part. I can right mouse click and say shell. Again, I like to start to drag to kind of visually see what that's going to look like. And then I can give it the thickness. So in this case, 0.06. And again, I got that dimension off of the drawing. Now, hopefully you're seeing, like, I've hardly ever had to go to the menu across the top. And I really emphasize that in a lot of my live streams. Everything's right at your fingertips, right? You right mouse click, here's the shell command or the extrude command. The marking menu, has the whole command and repeat the last command, etc. You're not having to find which command to use. Okay. Now we're going to start creating some of this geometry that you see on the top, mainly these 4 standoffs. They're one's kind of hidden right here, but you can see them, those 2 there and those 2 there. And again, we're going to use some existing geometry to help us out. So I'm going to create a sketch on this top face. And the gear housing sits on top of this part. So you'll see how this kind of fits up inside. And let's go ahead and turn off our motor gear base. And you can see these 4 plastic standoffs are going to be registered into these recessed counterbores on this motor gear base. So what I did is, if I have the motor gear base turned on, you can't really see those standoffs very well. So I went ahead and turned off the body. I'm going to do P for project, the project command. And then I'm going to project these holes. Now, I like to project the face more than the edge. And the reason for that is, to me, like, this is, like more than just, it's like geometry, right? Where this is more just like an edge. And so if this geometry were ever to move, so would the projection. So I'm going to go ahead and project those faces. Now, if I projected the edges, they would probably move also, but again, this is just personal preference. I'm kind of saying these are the faces I want to project. And you'll notice this projection link is turned on. That's really important. What that means is, if the geometry that was used to create the projection were to move or to change, so would the projection. And you're going to see this is going to come into play in our next live stream. I'll foreshadow you here. There's going to be some errors that happen once we move forward, and we're going to have to end up moving some of these standoffs, and you're going to see how cool that is next time. Okay, so you can see I projected those faces of those holes, and they projected onto my sketch. So I don't need to see the gear housing anymore. Okay, I'll turn this body back on, and I kind of like to look at it from the top. I can tell I'm still in my sketch because of this Finish Sketch button. And now I'm going to start defining the basically the counterboard part. So let's do a circle. It's 0.333 in diameter. So we can kind of see that. Now all 4 of these are going to be the same. So check this out. I'm just going to randomly draw some circles that are obviously centered, but I don't care about what size they are. Okay. Then I can come back and say, I'm going to use this equal constraint. I want this circle and this circle to be equal. And you can see how that changed. Same thing with this one and this one. Now all 4 of these are equal. So if I were to change this, to 0.5, for example, all of those would have to change to 0.5. So neat little trick. Instead of having to draw a circle, type in 0.333, and then draw another circle and type in 0.333, etc., etc., you just do one and use the equal constraint. Okay, here's another tip. Hopefully you know this. I could hit Finish Sketch right now, but notice I can also select my profile. So I'm going to go ahead and select these 2 profiles. I'm going to right mouse click, and you'll see it shows me the commands that make sense. Extrude and extrude. And I get asked all the time, what's the difference between those 2 extrudes? Well, the first one with the blue icon is a solid extrude, and the one with the orange icon is like a face extrude. There'd be like no thickness to it. It would extrude just a face. So 99.9% of the time, you're probably going to want to use this blue extrude. And you'll notice I didn't have to hit Finish Sketch. It just took me into the extrude command. Okay, and here you can see it's going to extrude that profile up. And let's do 0.16, again, according to the drawing. And of course, I want this to join to this part. So I'll say OK. And there we go. Okay. Now you'll notice a little issue here. We can't see through the part. And we're going to fix that here in just a moment. So what I'm going to do is I'm going to create a counterboard hole. In fact, let me jump to the drawing here real quick. And you can see that it's a counterboard hole. Okay. We can see that. Which one is it? No, it's not cutting through on that section view. Here we go. Sorry, in the hidden view. So here you can kind of see the counterboard hole. Let me scroll down slightly. And this is the new information. We just added this in the latest release, where if you point to a hole feature, it fills out all of the information for you, which is huge. And people have been asking for this for a long time. So we can see that it's a 0.1 diameter hole that goes all the way through with a counterbore diameter of 0.21 with a depth of 0.1. So that's what these symbols mean. So I'm going to use that information. So I'm going to create a hole command. And I'm just going to click somewhere on this face. So I'm just going to click there, for example, and it gives me a quick preview. And the reason I click off to the side, check this out. I can drag this and you'll see that little white dot appear. That's the center of that surface, or that circular surface. So I'm going to snap right to that. And it snaps to it. Okay? Well, now I can come in and say what type. It's going to be a counterboard hole. What's the extent? Well, I want it to go all the way through. So it's going to cut all the way through. You can see that there. And then I'm just going to fill in the information. So the hole was 0.1. The counterbore diameter, according to the drawing, was 0.21 with a depth of 0.1. And you can see it's kind of building that counterbore feature for me. And it's going to go all the way through. So we're basically fixing the problem of it not going all the way through. So I'll say OK, and there we go. We just kind of created this little standoff. I'm going to repeat the last command. So I'm just going to drag, right mouse click and drag straight up. And you'll notice that it's remembering my last settings. So if I click on this face, it remembers all of those settings. Except for my extents, it doesn't know, do I want to go through all again? So I'm going to go ahead and drag to that point I'll say, yes, I want to go through all. And there we go. Pretty quick way of doing that. Now I want to create the other two little bosses. So I'm going to turn this sketch back on. So I expand, open my sketches. I'll turn on sketch 2, and there we see those. So I'll select that circle and that circle profile, say extrude. And according to the drawing, these come up 0.065. And again, I'm going to join. Now, these don't have a counter bore, so you're going to see we're going to fix this here in just in a moment. The next thing I want to do is to create this vertical standoff right here. So we can see two circular diameters, 0.24 and 0.36, and a height of 0.3. Okay, so I'm going to go back and edit this sketch. I don't need to create a sketch every single time for each new feature unless I want to. But in this case, a lot of this stuff is sitting on this face. So instead of creating a whole new sketch, I'm just going to come back here and edit this sketch. Okay. So I'll go ahead and do a circle at the center. So I hit C for circle. I'll do the 0.24, right click and drag straight up to repeat that my last command, which was the circle command. 0.36. Okay. I can click on that feature and say extrude. Now this time I'm going to do the wrong extrude so you can see what it would look like. So I'm going to say extrude and start to drag up, and you can see they're just like surfaces. They're open. They're not watertight or closed or anything like that. So that's the difference between those two different extrudes. Okay, so we're going to always want to use this blue one. So I'll start to drag up, and the height according to the drawing was 0.3. Again, it's going to join. I'll say OK. And now what we're going to do is kind of fix those holes. So I want to have a hole that goes through here, and also through here. So I'm going to use the hole command. Now this time you'll notice it says placement at point, single hole, or it says from sketch, multiple holes. And that's what I want to do. I'm going to do multiple holes at the same time. So I'm going to click on from sketch, and I'll click that point. And you'll notice because my sketch is displayed, even though I'm in 3D, I'm able to pick that point. And you can see it remembers my last settings. But what I want is just a simple hole that goes all the way through. That's 0.1 in diameter. And if I kind of rotate around, we can see that preview. And what this allows me to do is I can continue picking other points. So I'll pick there, and I'll pick there. And you can see that it's putting a hole all the way through at those 3 points. There we go. Pretty cool. So the next thing I want to do is kind of work on this, I guess I would call it an alignment feature. So we can kind of see, let me take a look at this. Let's zoom up a couple here. So looking at this part of the drawing, we did an offset of 0.09, and then we brought it back off of the edge of the circle 0.1. Okay, so let's do that, and I think the overall height is 0.68, so that all of these dimensions are going to come into play. So once again, I'm going to edit the sketch. Now you'll notice because I'm going back in time to edit this sketch, you don't see any of the 3D stuff that I've been doing, like all those standoffs and those holes or whatever. So that's the only thing that you kind of have to keep in mind when you go back and edit a previous sketch. You'll see all of my downstream processes are kind of grayed out. So just keep that in mind. Okay, So I want to offset this arc. So O for offset. Now you'll notice as I hover over this, it's wanting to do the whole thing. Well, all I really care about is the arc. So I don't want chain selection turned on. Now you'll notice it doesn't chain all the way around, and it lets me pick which line I want. It's giving me a preview. I know that's in the positive direction, so we'll go 0.09 according to the drawing. Then the next thing according to the drawing was there was like a vertical line. So let's just do a line, and you'll notice as I get near the line, it's going to snap to it. So I'll click there, and then I'm going to come down here, making sure I'm vertical, and it's going to snap to that edge there also. And what's neat about that is if I were to move that line around, it's coincident. You can kind of see it's coincident with that arc. Okay. But it's still blue, which means it's not fully constrained. Let's throw that dimension on there. It was from that line there to that point there, and it was 0.1. And watch what happens when I say okay. It moves the line back, and you can see that those points are still coincident. I now have the profile that I want. This little section right here, I'll say extrude, start to drag to kind of get a preview of what that would look like. And the overall height is 0.68, and join. So we just created that little offset. In fact, if I turn off the sketch, you can kind of see what that looks like a little bit better. Using existing geometry to help me with the design. Okay. On the drawing, these two edges are filleted, so I'm going to select those edges, right mouse click and say fillet. Type in the distance of 0.1. I get a nice preview of what that's going to look like. One thing you also notice with a lot of my live streams is I kind of do things in order. Like I'm going to finish designing this whole standoff. I don't do one thing over here and then one thing over here and then come back over here, because that kind of helps me with my timeline design. So it makes it a little bit easier to follow. How is this part being created? So if I look at my drawing, you'll notice there's a little notch at the top of this, and then there's also a rib. You can kind of see this rib right here. Okay, so this notch is 0.8 from the top, or I have a dimension over here, 0.6 from the top of the part. And we can see that it's about 0.24 wide. So I'm going to show you a neat little trick. I've done this before, but I really like it. It kind of saves having to have multiple sketches. I'm going to come back and edit this sketch. Let's zoom up a little bit. I'm going to create a rectangle, so R for rectangle. And then you'll notice it gives me the 3 different options for the rectangle over here. So I'm going to do a center rectangle. If I get near this edge, you can see that it's being coincident with it, but watch what happens when I get here. You can see a different icon appear, and that is the midpoint of this arc. So I just get near that point, and it found the midpoint of it. Now what I care about is the width of this slot. It's supposed to be 0.24, okay? And then I'm just going to type in like 0.5. It doesn't really matter for that. And you can see that that is fully constrained because it found the midpoint of that arc. But really all I care about is the width of this slot. I'll go ahead and select, I like to select all of these profiles right here. Honestly, all I really need is this one. But again, what if these walls were slightly tapered? Like if we came back and added a 1 degree draft or whatever, it could cause some sliver faces, what I call sliver faces, to appear. So I like to over exaggerate and say, I want to machine this whole thing away. You can almost think of it as like a flat end mill is coming in and cutting this whole section. So I'm going to grab that and I'm going to say extrude. Now notice what happened. Okay, I'm way back here in my timeline. So that little tip I showed you is really useful, but sometimes you'll go to use it and you get this result. And that's because I was editing that sketch and I said, okay, now let's extrude that profile. Okay, so instead, what I would do is, let me go ahead and I'm editing this sketch. You can kind of see that here. I'm done with my design. I'm going to say finish sketch. And now you can see it completed all of the steps in my timeline. Okay, so sometimes that tip is useful and sometimes it won't work depending on what you're machining and all that kind of stuff. It worked fine over here because we were just adding it to extra geometry. Okay, so now I'm going to select these profiles again. Again, I'm just kind of clicking through to select those because they're kind of buried in there. And you're like, well, this is in the wrong location. It needs to be up here. Well, you're correct. I'm going to go ahead and say extrude. And if I were to start to drag, you're going to see that it's going to cut that geometry away. Okay. But instead of starting at the profile plane, I'm going to say offset plane. And then according to the drawing, it was 0.6 up. So I'm going to type in 0.6, and now you can see it's taking that profile, starting 0.6 inches up, and then extruding. So again, instead of having to have a sketch on this face here, I was able to reuse the sketch that I have down here, and we're just telling it offset 0.6. How far? I'm going to say all, or I could say to object. I'm going to say to object, and let's just click on that face there. And if that face were to move up or down, this extrusion cut would have to move up and down also. So there we go. Hopefully that makes sense. It's a pretty useful tool to start your extrusion from a totally different distance. Okay. So what I want to do now is, give me a quick second here. I think I need to add the rib. So yeah, let's do that. So I'm going to create a sketch, a new sketch on the front plane, because I like to use the rib command. So in fact, you know what? I actually made a mistake here. I'm going to finish that sketch, and I'm going to undo. I actually wanted to do the rib before I did this notch. So I'm actually going to drag my timeline back a little bit before that notch. Okay. Then I can come in and create my sketch on this front plane. And I'm going to project some geometry. Now, I've shown this tip before. If it's a curved surface, you'll notice that when I project that, it doesn't project that curved surface edge. It only projects actual edges. So let me undo. I'm going to do P for project. That's for specified entities. This is for bodies. So if I click on bodies and then hover over this part, it's going to project almost like what you would think of as like a silhouette. So now you'll notice if I turn off the body, it's almost like a silhouette of it, and we see that edge. So that's a really useful tip, is if you need to project, circular items or cylindrical items, I usually project the body. Okay, I need to create a line here that's at a very specific location. So I'm going to just draw a construction line. So I'm just going to draw a line out here, click on it, and convert it to a construction line. I don't want it to be an object line. but that point is coincident to that edge. So I can move that line up or down. Let's control it with a dimension. That is supposed to be down 0.08. You can see that that's now moved. And now I have a point I can catch to. I'll go from there. Now I need to be really careful. If I get right here, it's going to snap to the middle, and I don't want it to be constrained like that. So I'm going to get to this edge and click so it's on that edge. And then I will throw a dimension from this edge to this edge. And you'll notice if I just clicking one edge, it wants to do a linear dimension, but by selecting a different edge, it now lets me type in an angle of 70 degrees. And watch what happens when I hit enter. It's going to pivot around that point, and it's going to move this point to make that line be 70 degrees. I'll finish my sketch, and I now have just a line that we know is touching this outside surface right here, and it's touching this top surface right here. This will allow me to use the rib command. So I'm going to say rib. What's the curve? That's the curve. Again, I like to start to drag to get a preview, and you're like, whoa, that looks really weird. Well, right here, flip direction. So I'm going to flip the direction, and now I get a preview. And you can see, this is the reason I like using that rib command. It's smart enough to wrap around this curved surface. According to the drawing, it's 0.05 in width. I'll say OK, and I now have that rib. Okay, and then this is where I kind of messed up. According to my outline, I was supposed to do the rib first, and then I was supposed to come in and do this rectangle, but I got too excited showing you this cool extrude offset command. Well, now I can just go forward one step, and there is my notch. It's still using that profile, and we're good to go. So it's pretty cool. If you make a mistake or you kind of want to reorder things, you can just do that in the timeline. Okay, where are we at? So the next thing we are going to do is to start creating these. Let me bring up my drawing here. These little ribbed standoffs. This is where the gears are going to end up being located. And we can see, let me scroll up a little bit. Sorry, too far. We got some locations of where they are, some widths, etc. Again, I'm just referencing this drawing. You can see I did a detail of this ribbed part. So just going to use the information from the drawing to create these ribs. So going back to my sketch one more time, I'm going to edit that sketch, and I'm going to start by creating the circles somewhere over here. So let's do the 0.075. I'll drag straight up to repeat my last command. This one is 0.19. Let's zoom up on that a little bit. And then I'm going to create a rectangle to kind of define the rib. So I'm going to do rectangle, center rectangle. And you can see how it's going to allow me to create a rectangle that's centered on those circles. The correct width is 0.05, or I should say the height of it. And the length of these are going to be 0.32. And there is that guy. Now you'll notice it is not fully constrained. I want it to be in line with this, so I'm going to do a horizontal constraint, that point there with that point there, and we can see it drop down. But again, it's still not fully constrained. So let's throw a dimension from that point there to that point there, and it needs to be 0.75. I was pretty close, but now when I type in 0.75, you can see that the lines change color. That's fully constrained, which is good, right? we want to try and fully constrain our sketches as much as possible. Well, while I'm here, I'm going to go ahead and create the other 3 rib standoff. Now, I know that the circles are the exact same size, so I'm going to just randomly draw a couple circles, like so. I'll use the equal constraint. I want that circle and that small circle to be the same, that circle and that circle to be the same. So I now know if I were to change one of these, they both would update. Now I'm going to use a rectangle to create the ribs. We're going to do it a little bit different. I'm going to say rectangle, center rectangle, and I'm going to get near the edge. Now I want it to be perfectly straight up and down, but you can see that it's not snapping to that. So I'm going to do it off to the side a little bit, again, just for visual confirmation. The width is 0.05, and the height is 0.1. Okay. Now I'll constrain that. That point is vertical with that point, and you can see how that moved over. Now I want 3 of these, so I'm going to use the circular pattern command. Now I talk a lot about, I like to do my patterns in 3D to kind of simplify my design, but in this case here I could do either. And I'm actually going to do it in 2D. So what are the objects? I'm just going to draw a small selection box around this rectangle. What's my center point? It's going to be that point there. And by default, it defaults to 3. But you could see I could do 4, I could do 2. I could have done this one like this. But you can see by doing it 3, there are 3 equally spaced rectangles, and I'll say OK. Now they're still not fully constrained, so I probably need to dimension this. So I'm going to go from that point there to that point there. Now you'll notice it's wanting to do like an angular dimension. Well, I want it to be a horizontal dimension. Now there's 2 ways you can do this. If you move around, you'll see it'll kind of change depending on where your cursor is. You can see you can change, is it a vertical, an aligned, or a horizontal dimension, okay? Or you can right mouse click and force it to be a vertical dimension, a horizontal dimension, etc. So I'm going to say horizontal, and that is supposed to be 0.44. So you can see that moved over. I'll do the same thing. I'll say that point to that point. It kind of wants to do an aligned. Well, let's force it to be a vertical dimension. And it's supposed to be 0.51. And we can see that that's fully constrained. I'll finish my sketch, and there are the rest of my 3D geometry, right? Because I said finish sketch, it went down the timeline, finished everything. And now I can go ahead and extrude these guys. So I'm going to just draw a selection box around that profile. But you'll notice it selected some profiles that I don't want. So I'm going to control select those out of there. I'll say extrude. How far? 0.2 according to the drawing. And then I'm going to do the same thing here. I'm just going to draw a selection box. I'll unselect the, oops, let me do that again. Unselect that guy. Say extrude. This is 0.07 up. Okay. Doing pretty good here. So we now have created kind of the main geometry of this motor gear base according to the drawing. So we now have something that looks like this. So the next thing we're going to do is start creating some of the other components, and you'll see, let me zoom out here. We've got a component called long shaft at 0.75 tall. We have short shaft, which is 0.63 tall. So that's what we're going to be creating next. Okay, so check this out. This is what I was talking about earlier. So I'm going to activate this top level assembly. In fact, I don't even need to activate it. Let me just right mouse click on it and say new component. Okay. And what it's going to do is it's going to create a new component at the same level as this. So you can see we started by creating one called motor gear base. Well, now I know I'm going to be creating multiple components. So I'm going to call this motor gear assembly. And I'll say OK. And you can see we now have a new component called motor gear assembly. Well, I want this gear base to be inside of that. So I'm going to just drag that gear base and drop it onto my gear assembly. And now, if I expand this open, we can see inside of this assembly, we have motor gear base. And if I right mouse click here and say new component, I'll give it a name. We'll call this, let's call it gear, let's see what we want to call it. Shaft, gear shaft. I'll call it gear shaft long. Watch what happens when I say OK. It put it inside this assembly. And again, this is why I really like using this new component here. It allows me to put it pretty much wherever I want. And you'll notice that the gear shaft long is active. I'm going to, because it's just a cylinder, I'm going to kind of speed things up here. I'm just going to use a cylinder primitive. Now I know it's going to sit on top of this face. Now some of you might say, oh, well, why don't you just create it right where it belongs? I could, but I like to create it out here in space and then use a joint command to put it where it needs to be. And that way, if anything were to change, that joint command would have to update also. So I'm just going to click somewhere on this face, type in the diameter of 0.075, type in the height of 0.75, and that's how quickly I was able to create that gear shaft. Now, like I said, I want to put this in the correct location. So I'm going to activate my motor gear assembly. Okay. I'll create a joint. I'm going to check my motion is set to rigid, which is what I want it to be. So which one do I want to move and where do I want to move it to? Well, this is the one I want to move. So you can see I'm getting get near that edge right there and go ahead and click. Where do I want it to go? I want it to go near this edge here. In fact, I might even turn the sketches off and making sure I'm grabbing to like actual geometry. So I'm going to zoom out so you can see what's going to happen here. I'm going to click there and you'll see that that motor shaft moves into place. I'm sorry, that gear shaft moves into place. And it's a rigid joint. We can see that with that little icon right there. Okay, I'm going to do that again. Right mouse click, new component. We'll call this gear shaft short. It becomes active. I'll do my primitive somewhere on that face, 0.075. And then the overall height is going to be 0.63. It's a little bit shorter. Now you might ask, why did I activate this assembly? Well, notice when I created that joint, it put it underneath that assembly instead of underneath the individual component itself. Again, it's kind of an organizational thing. I find it a little bit easier is to kind of have the joints at the top level of the assembly. So that's why I activate that. In fact, if I expand this open, you'll see there's the one rigid. We'll come in here, we'll grab that guy and that guy. It'll slide it over. We'll say OK. And now you'll see those are the two rigid joints. And remember, you can rename these. So I could call it gear shaft 1. rigid or whatever. So you can rename these if you want to. Okay, so now we have some place to put some gears, and that's what we're gonna do next. We got about 15 minutes left. We might go over. I know I say that every single time. So I'm gonna use the FM Gears plugin. Now we've used this previously. If you don't have this, you can go into the Tools menu and then go to Add-ins App Store and just search for FM Tools. Okay, so that's what we're going to use, or FM Gears. So I'm going to say FM Gears. You can do internal gears or spur gears. Now we want to do spur gears. Okay, and in the drawing, if I jump over here and scroll down, I've included little screenshots of the settings that I used. And then you'll notice we're going to modify these gears. In fact, these are actually two gears that we've combined into one. So that's kind of cool to make it look like this gear you see there. Okay, so the hole diameter is, according to the drawing, 0.075. Diametral pitch for this one is going to be 52. The number of teeth is going to be 48. My fillet radius is 0.009. And then my thickness is 0.09. Oops, 0.09. I'm going to zoom out so you can see what happens here. I'm going to go ahead and say OK. And it's going to take a second, and it's going to create this gear. And you'll notice that it's actually created a new component called spur gear, and it says 48 teeth. Well, now I want to modify this. So I'm going to make sure I activate that component. And now we can see, sure enough, everything else is ghosted out. This is my active component. I can expand it open. We can see the sketches, etc. And what I want to do, let me see if I can turn on my camera here real quick. I don't know if you can see it. Whoops. Can't see it really well. It's got like a little indentation in there. So we're going to create that recess in there. And then you can see that little tiny spur gear. So that's what we're going to be creating. Sorry, I threw the parts everywhere. So I'm going to click on this face, create sketch. And you'll notice, because this is active, this is where my sketches are being created. If I scroll down, there's my new sketch. And I'm just going to use the circle command to create a couple profiles. So let's do 0.3 and repeat my last command. I love that tip of just right-clicking and dragging straight up to repeat your last command. So there's the two circles. I'll click on this face and say extrude. Let's zoom up here a little bit so you can see what's going on. Well, I want to cut into the model so you can kind of see. It gives me a nice preview what that's going to look like. So that's in the negative direction. So I'm going to say minus 0.02. It's going to cut. I'll say OK. Now you'll notice that sketch turned off. Well, I want to do the exact same thing on the other side. Well, I could mirror that extrude feature, but then I'd have to have a mid-plane and all this kind of stuff. It would take a couple more steps. Well, instead, I'm going to turn that sketch back on. I'm going to select that profile again, and I'm going to say extrude. But this time, where's the start? I'm going to say from object. Last time we said offset plane and we typed in a distance. Well, I don't even remember what the thickness of this gear is, so I'd have to know that for that option there. But if I say from object and I click on this face, it is now going to extrude from that face. And I obviously want to go in this direction, which in this case is going to be positive. So I'll say 0.02. I'll say OK. And we used the same sketch to modify both sides. Again, hopefully you like that tip. If you do, please please give a thumbs up. If you didn't know about that, let us know in the comments. We're always curious what you guys find interesting, what you've learned from these live streams. Okay, so what we're going to do next is create that smaller gear. So once again, I'm going to use this FM gears. The hole diameter is going to be the same. The diametral pitch is going to be 70. And again, I'm not going to go into too much detail, but you can kind of see it gives you some examples of what that means. Now the number of teeth is going to be much less. It's going to be 12. And so we can kind of see what the pitch diameter, you can see this little blue line. So the pitch diameter is actually pretty small in this case. Now you'll notice it says the root fillet radius is too large. It can't be any larger than this. So I'm going to crank that down to that 0.08. Now the thickness is different, so be aware of that. It's 0.13. And I'm going to say OK. Now it's going to create another gear. It's going to be hard to see because it put it right on top at the origin of the other one. But you can kind of see if I rotate, we see this little small gear. Now I want to, you can see there's the 12 tooth, there's the 48 tooth. I want to position this in the correct location. So I'm going to say joint. Let's just grab this edge. And then I'm going to grab this like larger circular edge here, and you'll see it move that smaller gear in the correct location. I'll say OK. And I actually want these to be two, instead of 2 gears, I want them to be 1 gear. So I'm going to say combine. What's my target? I'm going to pick this larger gear as my target. What's the tool? I'm going to say that is the tool. And I want to join them together. Now, I don't want to keep my tools. If I had this checked, it would join them together, but it would also keep this gear as a separate component. I don't want that. I basically just want these to be joined together. I'll say OK. And we can see if we turn this body on or off, it's all one component. Okay. So now you'll notice in my timeline I have this spur gear, but it's basically empty. There's really nothing in it. There's no body in it anymore because we basically combined it with this guy. So I'm going to just right mouse click on it and say remove. I don't want that to be in my design anymore. So you can see it no longer shows up. Okay. Let's zoom out a little bit. Now I want to start positioning this gear in place. So once again, I'm going to activate my motor gear assembly. And we're going to create a joint. So in this case, I obviously want it to be a revolute joint. So I'm going to say revolute. What's the first position or the first component? I'm just going to grab, I could grab either this outside edge or this edge here. Doesn't really matter. And then I want to put this on this lower standoff. So I'm going to click right there, and you'll see it instantly puts that part, and it kind of gives me a preview of what that's going to look like. I'll say OK, and there's my part. Now if I try and rotate it, you'll notice it doesn't let me. And that is because you need to ground an object. An object needs to be stationary. And that's going to be this motor gear base. So I'm going to right click on it and say ground. So before I do that, you'll notice if I just drag on it, it moves around, right? But as soon as I come in here and say ground, I can no longer click and drag on that motor gear base. There's a little pin icon right there that says it's grounded. But now if I grab my gear, you can see that sure enough I can rotate that. So you'll have to ground your object. Okay, now these two gears are exactly the same. So I'm going to right click on my spur gear and say copy. Now I want it to be inside my motor gear assembly, so I'm going to right click on my motor gear assembly and say paste. Now when it does that, it puts it in the exact same location. So I'm going to drag this off to the side a little bit and just say OK, and you'll now notice that we have two separate gears. Now you might be saying, well, why is this one ghosted out? Well, that's this spur gear right here, and you'll notice that it's not inside my motor gear assembly. But I can just click and drag, like so, and now it's inside my assembly. Pretty cool trick. Now the reason it wasn't, it created it kind of at the top level when I used that FM gears, and then I needed to put it inside my motor gear assembly. Okay, pretty much the same thing. We're going to create a joint. I'm going to click on this bottom edge. Now be careful when you're grabbing this edge. You'll notice that it's grabbing this edge and the center of it. That looks good, but every edge has a start and an end point, and you'll notice right here is where it is. And if I were to click right there, I would get a really weird result. So make sure you're getting the result you want, which is the center of that edge. And the same thing here. I'll click there. We can see it's rotating. It's standing on top of that guy. It's meshing with that. But if I look at it from the top, you'll notice that these teeth aren't engaged correctly. But what's cool is I can come in here in the joint command. I can come in and rotate the angle to get something a little bit better. So it looks like around 5 is pretty good. So I'm going to type in like 5. That's a little bit too much, so let's do 5.5. And again, this is kind of trial and error. 5.4 maybe or something. That looks pretty good. That looks pretty centered, right? So I'm going to create this revolute joint, and it's going to start at the angle of 5.4. Okay, now if I were to rotate this gear, you'll notice it rotates, but nothing happens with that other gear. So we are going to create a motion link to link these two together. Okay, give me just a second here. Kind of looking at my outline, making sure I'm doing this in the order that I want. Actually, I guess I do the motion links at the end, so I apologize. I'm going to create the third gear here, and then we're going to do the motion links. For you eagle-eyed people, you'll notice the mistake I was talking about at the beginning. Notice our standoff here and here are blocked by the gears. And again, this is because, you know, I'm taking measurements with my digital micrometer off of this part, and I was getting confused which is top, which is bottom, all that kind of stuff. But I thought, we're going to have to fix this. This happens in the real world. How are we going to fix this? And you're going to see that in our next live stream. So don't worry about this for now. We will come back and fix it. Okay, so I'm going to create that third gear, the larger gear. So FM gears. We are going to go over just a little bit. I apologize. So the hole diameter is going to be a little bit different. This is going to be 0.12. The diametral pitch is going to be 60. The number of teeth is 64. And you can see that makes a larger pitch diameter. The root radius is 0.09. And the gear thickness is 0.15. And again, this is in the drawing. In fact, let's jump to that gear. So now we're creating this gear. You'll notice there's a little recessed notch in there, but these are the numbers right here. You can zoom up on them to read them. Okay, so it created that gear for me. I'm going to activate it to make sure it's the active gear. I'm going to go ahead and minimize some of this so you can kind of see a little bit better. Okay, I want to pretty much like what we did on the last gear, pretty repetitive. So I'm going to kind of speed this up a little bit. I'm going to create a circle that's 0.35 and 1. So there's one circle and diameter of 1. Finish my sketch. We'll extrude, oops, into the part minus, I think it's 0.02, I'm sorry, yeah, 0.05 in this case, according to the drawing. So we just created that guy. I'll expand it open. I'll expand open the sketches and turn that sketch back on. Just like we did before, I'll extrude from object. We'll click on this back face. Now, you'll notice it's also trying to click like edges and stuff like that. So make sure it's grabbing the actual face. You might have to move around. So I'm going to click on that face there. Say 0.05. It's going to cut into the part like so. I'll say OK. I need to add some extra geometry here. So I'm just going to click on that face and say extrude. And you'll see it's going to allow me to create a taller pin. In this case, just a distance of 0.1. Let me turn off that sketch. So you can see it originally was at this plane right here, and we just added another 0.1 to that. And that is right here. Okay. Then we're going to create that little notch on there. So I do need to create a new sketch. So I'm going to click on that face and say create sketch. I'll draw a circle, again, just referencing the drawing. It's 0.25 in diameter. I'm going to create a center rectangle. The width is what's really important here, so that's 0.17. And I'm just going to come out here into space somewhere. It doesn't really matter where. I'm just going to click. Now you'll notice I didn't type in a dimension, but these lines are not constrained. Well, I want them to be tangent to this circle. So I'll just come in here and say tangent. I want that line to be tangent to that circle. And because it's symmetric, it did it on both sides. And we can see that we are totally fully constrained. Now I have this this cool profile where it's kind of chopped off at the top and the bottom. I can extrude in. So in this case, it's minus 0.15. Oops, 0.15. And there's a shaft that's going to fit down into here that's kind of registered by this notch. Okay, almost done here. I'm going to edit this guy and create a sketch, create a circular profile of 0.24, and extrude that 0.1. So it has a little standoff also. And again, all of this was from the drawing. So there's that 0.1 right there that we just created, the 0.24. So you can kind of see what it looks like when it's all said and done. Okay, so we obviously want to position this guy. Now, just like before, it's outside of my motor gear assembly. So I'm just going to click and drag and drop it on my motor gear assembly. Let's go ahead and activate my motor gear assembly, and we can see that those are all three of our gears now. 1, 2, and 3 are part of this assembly. I want to position it in place, so I'm going to say joint, making sure it's a revolute joint, and I'm going to grab this edge here because this kind of sits down inside that standoff. So I'm going to grab that edge and that edge. Now you'll notice it doesn't look correct. It's actually like flipped over. So I'm going to hit this little flip icon, and now it looks better. So you can actually flip the orientation using that flip icon. And just like I did before, I'm going to take a look at this, and I can see that these teeth, they're engaged down here good, but they're not engaged here. So I'm going to just kind of drag slightly. to get pretty close. So it looks like around minus 395. So let's just try minus 3.5. Okay. Let's try 385. That looks pretty good. So again, it's trial and error. Doesn't really matter because now we're going to create these relationships between these gears. So what we're going to do is, if I grab on any of these gears, you can see that one rotates, and oops, and this guy rotates. Okay. What I want to have happen in next live stream, we're going to have a little motor that has a gear on it that's actually going to drive all of this stuff. So I want to create relationships between these. And under the Assemble menu, there's something called a motion link. So I'm going to say motion link. Now, what are the joints? So I'm going to say this first joint here to this second joint here. And now you'll notice when I click on it, they start to rotate and stuff, and it's kind of hard to see what's going on. I'll stop the animation, but basically, I'll leave it running. What it's saying is for every revolution of this gear of 360 degrees, this gear has to revolve 360 degrees. But obviously, this one's smaller. So for every 365 degrees that this rotates, this guy is going to have to not rotate 365 degrees. In fact, I'm going to say 90. And watch what happens when I say 90. And I'll say OK. We'll come back to this in just a second. But watch when I drag this now. So the first thing I see is it's going the wrong direction. Okay? So let's edit that motion link and hit reverse. I'll say OK, and now when I drag this, we can see that that is engaging correctly. So for every 360 degrees this rotates around, this one's only rotating 90 degrees. Now, I'm not going to get into gear ratios and all that kind of stuff. If you know how to do the math and all that kind of stuff, this was just trial and error. I typed in 45 and then 90 and then, all that kind of stuff. So if you know the math, I don't, you can probably figure this out better than what I did with trial and error. Okay, so that guy works correctly now. Let's now link this one to this one. Now this is a larger gear, so it's not going to be as simple as 90 degrees. So I'm going to say motion link, that revolute with that revolute. And so for every 360 degrees this revolves, this guy is going to revolve, and I'll show you the trial and error. Let's say 90, okay? I'm just going to start there. I'll say OK, and I'll start to rotate, and again, I can see that it's going in the wrong direction. So let's edit this, say reverse, I'll say OK, and I'll start to rotate, and I can see that it's rotating too fast and the teeth are not staying engaged. So I need to lower that number, right? So that's basically what I did. So we started at 90. Let's try 45. As I start to rotate, now I can see that's too slow, okay? So that's kind of the process that I did. So let's meet somewhere in the middle. Let's just do, I'm just going to say 65. Let's look at it from the top. And I'll start to rotate. And that's looking pretty good, but I can see it's still just ever so slightly slow. Now it's starting to disengage, right? So again, I wish I knew how to do the math. I used to know back in the college days. So I'm going to make that number just a little bit bigger, and I'm going to say 67.5 in this case. And I'm going to start to rotate, and we can see that sure enough, that number seems to work perfectly. So I went to 67. It was ever so slightly off, so I did the 67.5, and that's what seemed to fix it in my trial and error. Okay, so here's the fun part. Now, if I grab this gear and I start to rotate it, you can actually see that gear ratio is physically working. So this bottom gear is spinning pretty fast, the middle gear is spinning medium, and the large gear is spinning pretty darn slow. So there we go. Okay, now like I pointed out before, these gears are covering up these standoffs. We're going to fix that in an upcoming live stream. Make sure you tune in. Angelo is going to do a live stream next week based on cam. We've been kind of rotating every other week with that. The next one of this is probably going to be the last of the pencil sharpener. It's almost going to be 10 parts. So I've been really excited seeing people have been sharing screen captures of the whole assembly that they've built from scratch. That makes me feel great. Hopefully you're learning stuff from this. Post it out on the Fusion 360 Facebook group. Let us know in the comments in the YouTube channel how it's going for you, and hopefully you're finding these useful. If you have any other topic ideas you'd like to see, let us know. In fact, I had a customer send me a drawing and say, how would you model that? So that's going to be an upcoming live stream also, is how would you model that particular drawing. So with that, I want to thank everybody for attending and have fun fusioning.